Hello everyone. Today I would like to talk to you about web push notifications and more specifically how to implement them by yourself on both front-end and back-end side. My name is Maciej and I'm front-end lead at LiveChat. You can follow me on Twitter using the handle visible on the screen or scan the QR code. I tweet mainly about web development, JavaScript, TypeScript, React, and a whole bunch of funny quirks in the codes found during the way. At LiveChat, we have a vision of customers' communication without barriers, and we already offer a suite of products that fulfills this vision. And from the engineering perspective, building such products comes with variety of interesting challenges. For example, building a application that uses WebSockets with the thousands active instances and keeping it fast and reliable, optimizing resources usage under hard load, building a chat widget application that is launched hundreds of thousands of times every minute, and finally building dedicated web push service for distributing information from the product to our users, even if the application is not running, because this is like the key thing of the push notifications feature. So I would like to cover first a quick recap what our push notifications are, so we are all on the same page. Then we will dive deeply into the web push protocol to see how the theory and the spec is what it is all about. Next, we will see how the implementation looks inside the code, and we will need to look at the service workers to do so because they are required to handle push notifications. And finally, we will see the notification API, how to use it to display a native system notifications from the browser. So first thing first, what are push notifications? Probably most of you already know them, but just to make sure that we know what I am talking about. When you Google the push notifications term, you will see that it is an automated message sent by an application to an user when the application is not open, as I have said previously. And as a visualization, the push notifications are all those pop-ups that are coming to your screen or something new is happening in the application to your mobile phone or the desktop. So let's see the web push protocol specification. Just a quick mention, the whole web push protocol spec is written as the same way as other web API specs in the Internet Engineering Task Force RFC. Here are the references on the screen for the specific RFCs. Whenever we talk about the communication, not only the online communication, we mean some parties that are available in this communication and some information that is coming between these parties. In terms of web push protocol, we have three parties. There is an app server. This is our backend, so we are responsible for it. There is a web browser, our front-end application. We are also responsible for it. And there is a push service. This part we are not in control of, and we are not responsible for it, and what it is and where it comes from. The push service is a dedicated service offered by the web browser, I would say, owner. So for example, if we have a Chrome browser, the Google builds it. So the Google also offers a push service for the Chrome browser. But each web browser actually offers its own push service. So we start the journey in the web push protocol by sending a subscribe request from our front-end application, the web browser, to this push service. Fortunately, there's a dedicated method to do so from the push API. And when the push service receives it, he says like, okay, you are subscribed, here's your subscription object with all of the details. It comes to our front-end application, but we will not use it on the front-end side. It's actually dedicated for the backend. So we need to send the request to our backend application and send the subscription object to our application server. What does this push subscription object look like? It contains two main things, the endpoint and the set of keys. We will first look at the endpoint. So this endpoint is built from the host name. It represents the actual push service. And then in the path, there is a unique identifier of our subscription, which actually identifies our specific web browser and the service worker inside of it. We'll talk about it later. So we make, whenever the event happens inside our system, or it is done by hand on request or some webhook, and you want to send a push notification on our backend side, we simply make a request, typical HTTP request, to this endpoint from the subscription object, and that will go to the push service, and it will make the push service later send this to the web browser. But if we will do this just like that, we will just get an unauthorized request. Why? Because we need to authorize this push request. And there is a separate specification for the voluntary application server identification for web push built just for authorizing the request with the push service. It's pretty simple. We use, by the design from the spec, a JSON web token to do so. How many of you have used JSON web tokens? Yes, I have thought so. Most probably you have used them in a, like I would say, most popular form, which is using a symmetric algorithm for signing it. So we are using like a single secret stored in your application configuration. But in case of the web push protocol, we have two parties. We have our backend and we have a push service, and we need to authorize the request between them. And we are not in control of the push service, so we need to use an asymmetric way of signing the JSON web token. And it is possible, it's like alternative algorithm for it. So we sign it using the two keys, the public and private keys. And those keys, where they come from? We just simply generate them. It's similar like with an SSH. You generate a pair of keys and you use them. So you can generate a pair of 256 bits keys using backend configuration. And later, the public key will be given to the front-end app, so it will send it together with the subscribe request to the push service. And in the claims, in the data of the JSON web token, we need to put the URL, the host name of our application. This is obligatory. And optionally, we can attach the contact information to the application owner in form of the mail to link. And finally, when we have this JSON web token, we just simply put it in the authorization header. But instead of the bearer token, we use the web push as the name of the strategy. This is like by the design from the spec. And additionally, because we are using the asymmetric algorithm for signing, we have the private and public key. We additionally need to put a crypto key header to put this public key into it. So we finally have the properly authorized request came to the push service, and it was accepted. And later, the push service is responsible for like finding our web browser and our application, and send the push message as actually the push data to the web browser. But there is one more problem, because the message will be actually skipped. It will be received by the browser, but a browser will tell that it will not handle it. Why? Because we have sent raw payload and it was not encrypted. Unfortunately, because we have like these three parties involved, the application server, the push service, and our front-end application, we cannot just rely on an HTTPS protocol, and we need to encrypt the message payloads by ourselves. And we actually will use the same algorithm used by the HTTPS protocol. So that's the second part of the push subscription object. There is this keys object, which contains web browser public key. The private key, of course, is hidden. It's inside like the browser. It's not exposed to us. And additionally, this mysterious auth element that is like the common knowledge part in the signing algorithm. I'll talk about it a little bit later. So the message encryption, which is also defined by the spec in the web push protocol, looks like this. It's split between the user agent, our web browser and our application, and the application server. So the push service is not involved. Why? Because by the spec, it is expected that we are not trusting the push service. So it should not be possible to decrypt the information of the push service. So on the user agent, basically we are using the elliptic curve Diffie-Hellman algorithm, which uses for encryption the common secret, which is obtained always by combining the our private key and the public key of the other party. So on the user agent, we use our private key, like this is actually done by the browser, so it uses its own private key, and our vapid public key, which we have given during the subscription. And it gets this secret for decryption. And on the application server, we do the same, but we use our application server private key together with the public key from the user agent we have received here inside this push subscription object. And in order for this algorithm to work, we need this common information to synchronize between those two parties. And this just randomly generated on the user agent. This is this auth part. And then application server uses this directly from the push subscription object. It's actually pretty complex, but I have found this like really beautiful representation using explaining the complex math using something that we already know. So this is the elliptic curve Diffie-Hellman algorithm using the mixing panes explained. So you actually have this common panes. This is this auth part. So it's this common information. Then we have the secret colors, that they are the secret private keys. We don't exchange them. Then we have the public keys. And as you can see, the public keys are created by combining this common information with our secret information. Then we exchange them. And on the other side, when we combine this public exchanged information with our secret information, it looks like we will get the same color at the end, this brown color. And this is this generated secret used for encryption. As you can see, we never exchange the secret colors, so the information is secured. So now let's see how this is implemented in the code, and we need to quickly recap the service workers because we will need them. Service workers serves for us for the bunch of reasons, but we don't have time to talk about all of them, but we definitely need to talk about how to register this service worker to work with them. So we quickly check if the service worker is available and we can actually use this API. Next, we call this globally available navigator.service worker that get registration. This is an asynchronous method. It will give us information if we have the service worker registered for our application or not. So we check it. If it exists, we have the registration of this instance of the service worker, and we have used it. For example, we can update it or do other things with it. If it does not exist, we can register the new service worker, calling navigator.serviceworker.register, providing the path to the script. It will be downloaded and registered as a new service worker instance, and we will get from this method this registration object. And we can do a lot of things in between. And finally, when we will decide to do, we can also unregister this service worker, calling registration.unregister. So we have this active service worker for application done. Now let's see at one of possibilities that service worker gives us, and it is exposing a push API to us. So on the active service worker registration, we have this push manager object when we can call the subscribe method. This is asynchronous one, and this is the subscription call that will be made to the push service. So we, as a front-end developers, don't actually need to make any requests by hand to this push service. We don't need to know which one it is, where it is stored, what is its domain name. We just call the subscribe method, and the proper push service for current web browser will be called by the web browser, and we will receive the push subscription as described in the spec. And in order to do such subscription, we provide an application server key. This is this public key from the key pairs generated for our server configuration. And there is this user visible only true mysterious param. This is actually a funny part about the web specs, because when this push API spec was like an experimental and in the draft stage, there's this concept that actually push messages can be like received and the application can display actual notification or not. It was decided that during the subscription, we will have this option, so we can tell if this notification, if these pushes will be only available for the users or not. But it turns out after it was released in the final version, there was an agreement between web browser makers that actually we always want to display notification when the push arrives. So we have this dead use visible only property that always need to be set to true. Sorry. And when we have the subscription, we need to send this to our server, calling like arbitrary, for example, API push subscription request. This is our own server we created, so we need to prepare such endpoint so our server can handle it. And we simply send it as a regular JSON object. And on our server side is like the draft implementation, for example, of this endpoint handler. We received this push subscription in the body, and we need to store it somewhere, for example, in a database under some ID that, for example, corresponds to, I don't know, like our user ID or something like that. And next, we are in the phase when we want to actually send the push notification. So we can yet again implement in a variety of triggers on our server side. For example, we can just make an ordinary API endpoint, for example, API.notify, where if it will be called, it will make it will cause the server to send the push notification. So how it looks like? We get the subscription object exactly as it was generated in the web browser from our database using the proper ID. Then we prepare the push message payload. For example, here I have built the notification object with a title. And the last thing, we need to prepare some options that will be used for all of those authorization and end message encryption, like the subject for JSON Web Socket claims, public server key, private server key. Remember that the keys for the message encryption are inside the subscription object. And now is the part when we should do all of those complicated things with generating the proper JSON Web Token, sign it with an asymmetric algorithm, encrypt properly the message. But fortunately, there are a wide range of libraries available for various frameworks and languages. And it's actually expected to use such library and don't do it all by hand. You can think of it like a missing part to supplement the push API on the backend side, because on the frontend side, we have the push API available available from the service workers by the browser. On the server side, we need to, for example, npm install the web push package for the Node.js. This is like the preferred package for Node.js, the web push package. And this such library gives us ready-to-use method, like seen here, the web push.send notification asynchronous function that will actually get the push subscription, the payload we want to send, and those options containing the public private key and the subject, and will do all of those complicated work for us. So it will properly sign the JSON Web Token, attach it to the authorization header, attach the crypto key header, encrypt the message payload that we have added, and finally grab the endpoint from the subscription object and send the proper request to this endpoint. And all of this is done in this single web push.send notification call. And when this call is made, it goes to the push service, as I have shown earlier. And then the push service found in the internet a proper web browser with the proper service worker instance, and sent to this web browser this push message. And the web browser acts here like a proxy, because the web browser is the native application on our device. It receives this push message data, and it finds a proper service worker registration in its registry, spin up this service worker, and dispatch the push event on this service worker. So inside our service worker script, we can attach a proper event listener using the self globally available object inside service worker context. So we call the self that at event listener push. This is the name of the event that will be dispatched by the web browser on our service worker when the push message come in. And we pass the event handler where we get the event representing this push message being received. And inside this event object, we have the data, the payload that we actually sent from the server. So after quickly we can grab the notification object, deconstruct it, grab the title and additional options, and actually call the show notification method on our service worker registration. This is the special method from the notification API that allows us to show the native notification on the user device, and we provide the title and additional options. But we need to talk about the last thing, the notification API, because if we will just simply call the show notification, it will just don't do anything. Why? Because the notification API is one of those web APIs that require the user permission to be granted to actually we can use it. So we need to use the notification API and see how it works, and manage the permissions first. So we can use the notification.permission globally available. It is a synchronous property that allows us to read the current state of the permission for our application in terms of notifications. It can have three values: denied, granted, and unknown. If it is denied, we just don't receive the permission, so we don't do anything. If it is not denied, we can check if it is maybe granted. If yes, we can show the notification. For example, the simplest way from the application itself is just creating a new notification object with the title and optional options. And just calling this constructor will make the notification appear. So we don't need actually to use the internet, send any requests to simply show notification. We can do it directly from the application. And if it is neither denied nor granted, it means that it is unknown. So we need to request permission by calling notification.request permission. This is yet again a asynchronous method that will give us a permission, and this is exactly what brings this pop-up, probably known to you, from the web browser asking for user for the permission. And we can go back to our service worker, this last line that previously didn't work. And now when we have properly configured and notifications, we have asked the user for the permission, calling the show notification will eventually make the user receive the notification. So the main key takeaway from this presentation I would like you to bring is that web push notifications, whenever you hear this term, it's actually two separate web APIs, the web push API and the web notification API, glued together to build this common user experience of web push notifications. And that's all from me. Thank you very much.
Okay, we have some questions. Reminder, the app for questions, the QR codes are on the stands there and it's in your browser history. And now the question, what about language translations? Should we send just a code that would be translated before showing on the front-end side?
Well, actually, you can achieve it in a few ways. You can send already translated message if you have some metadata about your user and you know, for example, he uses this very specific language and you can offer the proper version. If you don't know it and you want to base this translation on the current location or something, you will need to handle it on the front-end side. But this actually will be exactly the same case with sending any other arbitrary data to the front-end application, no matter which communication protocol you will actually use.
Okay, and one more. Can we have push notification without the intermediary of push service, just pushing notifications straight from the server to the client?
Yes, if you will build your own web browser. Actually, because this is how the push overall, the push messaging work as an architecture. You need to have this pipe open from the application or your system to which the data are sent. So for example, on the mobile operating systems, you have for example, on the iPhone, the actual Apple is in charge of the push service that is only available service that can actually push messages to iPhones. You can't just push messages from any arbitrary services to iPhones, and this is exactly the same on the web. When you have the web browser, in order to push, for example, to the Chrome push messages, you need to do this from actually it's like the Firebase service. This is the one that Google Chrome uses. So that's why the push service is necessary. And we have this whole web push protocol specification to know how to actually send proper data to the push service so it will for us send this to the user. But actually the side note, in comparison to the well-established mobile push notifications on the mobile phone, the good part in a web specification is that we have multiple push services. So we don't have this single one with the example of an iPhone that only Apple can do that. With web browsers, we don't need to use this very specific. We have from the front-end side, we just build our code and it will be handled no matter which web browser will be running it.
Okay, thank you.
Thank you.